Good morning all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the video lecture series on discrete Fourier transform, that is nothing but overlap add method. See, this is the empathy part of section convolution. Difficult to filter long data sequences, real-time filtering of long data sequences slow. Sectioned convolution, the response of an LTE system for any arbitrary input is given by linear convolution of the input and the impulse response of the system. The input sequence or impulse response sequence is very much larger than the other. It's very difficult to compute the linear convolution for the following reasons. The entire sequence should be available before convolution can be carried out. This makes long delay in getting the output. Large amounts of memory is required to store the sequences. In this technique, the larger sequence is sectioned or splitted in the size of smaller sequence. Then the linear convolution of each section of longer sequence and the smaller sequence is performed. The output sequences obtained from the convolutions of all the sections are combined to get the overall output sequence. There are two methods of sectioned convolution. They are overlap add method and overlap save method. First we can see the overlap add method. In the input data can be given. First we can find out the x1 of n. The larger sequence is splitted into the smaller amount of subsequent data. That is nothing but x1 of n, x2 of n and x3 of n. Now x1 of n is added, m minus 1 zeros is added with x2 of n. In x2 of n having m minus 1 zeros can be combined with x3 of n. This is the output data, y1 of n, y2 of n, y3 of n. M minus 1 points added together, y1 of n and y2 of n can be added, and then y2 of n, y3 of n, m minus 1 points can be added in overlap add method. This is the another example, x1 of n, x2 of n, x3 is splitted into smaller sequences, m minus 1 zeros, m minus 1 is that can be added to get the input sequences. Output sequences also we can add m minus 1 points. In y2 of n, y3 of n we can add m minus 1 points. We can get the overall output sequence in overlap add method. Now how to find out the overlap add method? Divide the longer sequence into smaller sequence, that is x of n long sequence, h of n small sequence. Then divide x of n into x1 of n, x2 of n, x3 of n. Length of x1 of n or length of x2 of n or length of x3 of n which is equal to length of h of n. Next step to find the y1 of n. y1 of n is equal to x1 of n into h of n. Similarly for y2 of n is equal to x2 of n into h of n. y3 of n is equal to x3 of n into h of n. We can combine all the outputs y1 of n, y3 of n, y3 of n. We can get the overlap add method output sequence. Now we can see the problem. Find the linear convolution of x of n is equal to 1, 2, 3, 4, 4, 3, 2, 1 and h of n is equal to minus 1, 1 using overlap add method. First we can divide the longer sequence into smaller subsequences. Longer sequence x of n, h of n, small sequence. x1 of n can be divided into 1, 4, x2 of n 3, 4, x3 of n 4, 3 and x4 of n 2, 4. Therefore, length of x1 of n or x2 of n, x3 of n or x4 of n which is equal to length of h of n. Next one we can find the y1 of n. x1 of n is 1, 2, h of n is minus 1, 1. By using tabulation method, we can find out the output sequences y1 of n is equal to minus 1, minus 1, 2. Next one, y2 of n is equal to x2 of n into h of n. x2 of n sequence 3, 4, h of n minus 1, minus 1. We can multiply and then add, we can get y2 of n is equal to minus 3, minus 1, 4. Similarly for y3 of n, x3 of n into h of n, x3 of n is 4, 3, h of n is minus 1, 1. Minus, we can multiply and then combine, we can add together, we can get it as y3 of n is equal to minus 4, 1, 3. y4 of n is equal to x4 of n into h of n. x4 of n is 2, 1. h of n is minus 1, 1. Now we can multiply and then add together. We can get y4 of n is equal to minus 2 comma 1 comma 1. Now we can combine all the outputs n, y1 of n, y2 of n, y3 of n, y4 of n. Minus 1, minus 1, 2, minus 3, minus 1, 4, minus 4, 1, 3, minus 2, 1, 1. Now we can combine all the minus 1, minus 3 plus 2, minus 1, minus 4 plus 4, 0. 1, 1, 1, 1. Therefore, output sequence y of n is equal to minus 1, minus 1, minus 1, minus 1, comma 0, comma 1, comma 1, comma 1, comma 1. Now we can see the applications. It is used in communication signal processing. To remove the noise which are added during transmission can be removed using filter, which the operation is involved in convolution. Now we can see the assessment. List the methods involved to compute section convolution. There are two methods, overlap add method and overlap save method. Mention some applications of section convolution. It is used in communication, signal processing, etc. What is meant by section convolution? The larger sequence is splitted or sectioned into smaller sequences. Determine linear convolution of x of n is equal to 1, 2, 3, 4, 4, 3, 2, 1 and h of n is equal to minus 1, 1 using overlap add method. Now we can combine length of x1 of n sequence is equal to length of h of n. Similarly, we can find out by using tabulation method. We can get the output as y of n is equal to minus 1, minus 1, minus 1, minus 1, 0, 1, 1, 1, 1. The output sequence obtained from the convolution of all the sections are combined to get the overall output sequence. Thank you.